In this video, we're given a question with an X and Y list here, and we want to answer some questions regarding linear regression. And the first thing that we have to do is use a calculator to determine what that linear regression is, or the line of best fit. So I'm going to use an Inspire calculator software to get that done. The first thing we need to do is add in all of our data into the calculator, and we're going to add that into the list and spreadsheets. So we need to add that page first. So I go to my home screen and I click New Document. I'm not going to save anything. And again, the page that I want to add is the list and spreadsheets page. And then I want to add in all the X values into my calculator. So under column A, I'm going to title that X. I type in X, hit enter, and then I arrow down to the first row here, and I begin entering all my X values. When I'm done entering in all my X values, I want to arrow up to the top of my page here, and I'm going to title column B Y, hit enter, move down to the first row again, and then enter in all my Y values. Now that my data is entered, I want to add this to a scatter plot. I want to do that in a data and statistics page. So to add in that page, I'm going to hit Control and then Document, and then click number 5, Add Data and Statistics. And then to plot all my X variables, or I'm sorry, X values, I click this bottom part right here, and I select X. And to plot all my Y values, I hover over here, I click it again, and I'm going to select Y. Now that we have our scatter plot done, we want to add in our linear regression. So we go to Menu, Analyze, and then down to Regression, and we're going to select number 1, and you could do number 2 as well. Either one works, but we'll go with option number 1 for now. And there is my linear regression. Now what pops up here is our equation, and that's going to be the equation of the line of best fit. And we're going to use that to fill in our table. Now that we have the equation for our line of best fit, I'm going to go ahead and fill in this table. That's part B. So the first thing that we want to fill in is the column with predicted Y values. And I start off by writing the equation of the line of best fit, which is Y equals 5.75. And then we're going to plug in our X value here, which is positive 1. Right here, we use these X values. And I'm going to take away the y-intercept, which was 3.5. Now remember that 5.75 here times the x value minus 3.5, that was taken from the Inspire calculator. Okay. Now if I calculate that, I'm going to end up getting 2.25. So my observed data when x was 1 was 2. That was the Y value. Okay. Now the predicted Y value with the line of best fit was 2.25. So that kind of summarizes what all that means. So let's go ahead and do one more. I've got Y equals 5.75. That doesn't change, but I'm going to plug in my X value, which is 2, and then finish off writing that equation, which is minus 3.5, and that's going to give me 8. So I'm going to go ahead and do that for the rest of this column. Now that I have all the Y values done for the predicted column, we're going to go move on to our residuals. And now to calculate the residuals, all you do is take the Y values of the observed data and then subtract the Y values from the predicted data from that. So you got 2 over here, and then you subtract 2.25. 0.25. That's going to equal negative 0.25. And that's the residual amount. So again, we take our observed y value, which is 13, and then we subtract the predicted y value, which is 8. That gives me an even 5. I'm going to go ahead and do this again for the rest of the residuals. So there are all my residual values. After we got our residuals, we're going to go ahead and square each one of those to give us our residual squared. So all I do is take 0, well, it's going to be negative 0.25, and I square that. Okay, and then I take 5 here, the other residual, and I'm going to square that, which gives me 25. And once again, I'm going to square all these residuals and come up with the rest of my column here. Now the next part of the question is asking us to add up all residuals squared, but I wanted to go back to the calculator and show you how to do it there first, and then I'll show you how to do it by hand in this sheet. Now the next part is asking us for the sum of residuals squared, and the nice thing is that the calculator does that for us, as long as it's a linear regression, right? So if we go to our menu, analyze, down to residuals, select number 1, it says show residual squares, and if you do that, our equation, well, right underneath our equation, it says the sum of squares. That's the sum of residuals squared. So that value looks like it's going to be 115.25. And the second part of that question is asking us, well, do we want a smaller number for that, or do we want a bigger number for that? Well, to do that, let's get rid of my linear regression, and I'm going to add in a movable line. And you don't have to do this if you don't want. You can just watch along. So I go to Menu, Analyze, and I'm going to hide my linear line. So I do that. Now I'm going to go back to Menu, click Analyze Graph, and I'm going to add in a movable line. So now this line, like suggested, it moves, right? I can move it around, and my equation moves accordingly, right? I'm going to go to Menu, Analyze, Residuals, and then show my residual squares again, so that this value comes up, okay? And I'm going to adjust my line of best fit. And right now it's a good line, right? But if I move it all the way down here, where it's not going through any of these points, right? It's way below the data. It's not good at all. Check out that sum of squares number. It's almost 2,000. It's 1,960.64. So the number got really big. Well, that doesn't seem so good. Let's move back my line of best fit so it goes through some of the data here. And then my sum of squares value is down to 118.145. So it seems as if the line of best fit goes through most of the data, that sum of squares number is going to be smaller. And if it doesn't go through a lot of it, or maybe it's a bad approximation, it's going to be a lot higher. So you definitely want a smaller number for that. Now you could always get this when you're doing a linear regression, but unfortunately, and maybe there's a way, but I don't know how to do it. I don't think that you could get this number if there's a quadratic function or an exponential function. You could use some formulas in the list and spreadsheets and calculate it that way, but it doesn't just pop up as nice as this. It's only for the linear regression. Now, An important value is the sum of residuals squared, and this was talked about in the part with the calculator, but if you take all of the residuals squared here, so all these values that we just got, add them all together, you're going to get that 115.25 number that was talked about in the calculator part, okay? And then I think we also talked about the lower the number is, the better line of fit everything is, okay? And then if you got a higher number, then it wouldn't be as good. Now, something that people often ask is, well, why do you even bother squaring all these residuals? Why don't you just add up all these residuals? So if you go ahead and take all these residuals here and add them together, that number is going to be 0. Okay, when you take into account all the negatives and all the positives, when you add these together, the line of best fit, these will all equal 0. So then that, to determine how good that line of best fit fits the data, uh, like you wouldn't have anything because it would become 0. That's why you have to square those values, and then that would give you a number where you could judge like how good is that line of best fit. At this point, we've thoroughly answered A, B, C, and D. The last part we want to do is E, and it's asking what value can you predict Y to be when the value of X is going to be 12. Now, let's go back to this screen, and it's like, all right, well, what happens when X is 12, right? We want to use, just like we did here, our equation of the line of best fit, which is 5.75, and I plug in that value of 12, which is going to represent my x, and then I continue writing that equation with line of best fit. So we got minus 3.5. That answer is going to be 65.5. So imagine if we had all of our observed data plotted on the scatter plot again. If we moved over to where x was 12, you could expect to possibly find some data around 65.5. And that covers everything that we needed to do.